Here you can see this quote. Maybe in just 3 to 4 words, who can just explain the gist of this quote? So the quote goes like, we have a system that is able to take the trust out of the hands of people and institutions and put it into a system. Now, this is a very famous quote that was quoted by a person known as Andreas. So what does this mean? We'll try to cover this in context of blockchain. So these will be the topics that we'll be covering. We'll first try to understand the blockchain. Then we'll try to cover what exactly are the limitations of it, how blockchain has evolved over the past decade, then what kind of solutions are there, what is interoperability, and what are cross-chain solutions. Then we'll be going ahead for the DeFi, decentralized finance, and blockchain finance. Some of the typical use cases that are there related to blockchain, such as NFT, non-fungible tokens, digital assets. Then we'll also try to look into the blockchain and Internet of Things integration. And then we'll cover the environmental impact and sustainability, followed by blockchain and governance and identity, quantum resistant blockchains, emerging trends in blockchain research, as well as the predictions for the future of blockchain. Okay. Now, after this, if in case any one of you has any doubts related to any new topics which are not included as part of this session, you can shoot those doubts as well. We'll try to pick those as well. Okay. Now, even before proceeding, I'll just request you one thing. So, how many of you have a good imaginative power? How many of you can imagine things quickly? Or how many of you are good in that? Just put yes or no, maybe in the chat. Okay. So this is something which I'm asking because throughout a session, I'll be asking you multiple times to imagine some scenarios. I would request you all to think from a perspective wherein you are able to imagine something, some scenario. We'll just try to discuss it in terms of scenarios. It will be related to our real world examples only. Okay. All right. So now we'll just try to look into what exactly is blockchain. So what do you think a blockchain is? Let's try to understand it from a very basic or layman perspective. You just try to imagine a digital book that records transactions. But here's the twist. Instead of being stored in one place, the book that you are having, digital book, it is duplicated across thousands of computers all over the world, all around the world. Every time a new transaction will happen, everyone on the network will agree on it, and then that particular information will be added to the book. Now, once something is written in this book, it is there forever and no one can change it. So this digital book you can consider as a blockchain. It's more like a public ledger that is super secure, it is transparent, right? So here it says like a revolutionary technology that underlies cryptocurrencies like Bitcoin and Ethereum. Now, whenever we talk about Bitcoin, these are some of the buzzwords that pop up, like Bitcoin, Ethereum. So what exactly these are? These are just the digital currencies we might be knowing, right? Now people are using it for much more, not just related to or not just limited to the cryptocurrencies like Bitcoin and Ethereum. We have a decentralized and distributed ledger that works in a peer-to-peer fashion. It just tries to record and store all the transactions across multiple nodes, or we can say computers that are there as part of the network. Now, the key features include transparency, immutability, and decentralization. Now, we all know what exactly is a transparency. It means whatever transaction will be committed, you might not be able to see who has committed the transaction, because there is one more feature which is known as anonymity. That means your name will be there as an anonymous user, some sort of a hash. How many of you know about hash? Give me a heads up in the chat. Okay, Gokul says yes. Who else? Anyone has idea about hash? Okay. Or if you have heard about this term checksum anytime, whenever you're browsing through some open source platforms, you're trying to download some tools which are open source or which are there on open source websites, right? Okay. All right. So basically, hashing means whenever we are passing in some particular data. Now it could be a one letter word, it could be a letter, it could be a word, it could be a sentence, it could be a paragraph, page, anything it could be. Whatever we'll pass into some hashing algorithm, it will just return a fixed length output. Now this hash is something which is used. So first of all, it is an irreversible phenomena. It is not like encryption, wherein you can use some sort of a key to just decrypt that information. Hashing is irreversible, which means you can't reverse it. So whatever data that you have processed out of that hash, it cannot be reversed. Now, what could be the business level use cases or implications of this thing? Now, these all things which we are discussing. These are just some of the concepts related to cryptography. Now, blockchain, when we talk about blockchain, it uses multiple cryptographic techniques altogether to make it more and more secure. Okay, so hash is one of them. Now, whenever we will be talking about hash, you need to understand that, okay, some data is there, but it is not in the normal readable format. It will not be like, let's suppose uh, if you have any name. Now you can't understand what name it is when it is hashed. So when we talk about anonymous feature, it means whatever name that will be there, that will also be hashed. So it works in such a way that everything is hashed so that the identity remains anonymous. But at the same time, you will be able to see that, okay, this particular public address, public IP here means your identity in a public world. So that is denoted by your public address. Now, whenever you will be doing some transaction, it will be recorded on the ledger that, okay, this particular person with public address, this one, has sent or transferred some particular amount of Bitcoin, Ethereum, any other cryptocurrency per se, to some other account having public address, this. Now, this particular transaction is stored onto the blockchain, which you can check through the blockchain explorers. So if any one of you has ever used these blockchain explorers, like there is this ETH explorer is there, ETH scan is there, right? So all these explorers are there where you can see how exactly the transactions are being displayed. So that is also one of the features of the blockchain when we see. Next is immutability. Now we know what exactly is immutability. It means something that cannot be modified, something that cannot be manipulated, or something that cannot be altered. Now, once we have written that, okay, person A transferred 10 bitcoins to person B, we are not saying it will be it will be a false transaction or something. But once the transaction is done, then we can say that, okay, now no one can erase or no one can manipulate the transactions. You can't say, you can't change these three factors: person A, person B, and the amount that has been transferred. These are the three key metadata things of a particular transaction, right? Whenever we transfer some amount to someone, what are the three major things that make that transaction? The sender, the receiver, and the amount, right? So this is what a blockchain is. Now here, if you'll see, it's just a brief sort of a structure that I'm showing here. This is a Genesis block. So the first block that is there, within any blockchain network is known as Genesis block. Then we have second block, third block, followed by n number of other blocks, right? And then it just creates a chain in that way. Now here, an important point to remember is how these blocks are connected. So I'll just try to explain you in a very uh, basic manner how exactly these blocks are connected. Now just imagine that this first block which is there, it is having some data. Now that data could be some transaction, some details related to the transaction, what was the amount, who sent to whom. Okay, all those details will be there. Now, since we discussed about the hashing part, everything will be hashed. It will not be like some name is given, just like some bank receipts or something. Nothing like that. Everything will be hashed. It is also there for storage purpose also, because we need to have a precise storage. It can't be like we are having 1 GB or 1 TB of node and then we are having multiple blocks. It is never in such a way. We need to have a concise size for this, like 1 MB, 2 MB, 3 MB. So usually it is lesser only, right? But just to give you an idea, everything we'll be having in terms of hash here. Now we'll be having hash of the transaction, then we'll be having hash of the block. So at the end, we'll be having the hash of the entire block. So we have Merkle root, some other elements are also there, which maybe you can look into later if you want to get some more detailed understanding of what exactly a block is having. But here we are just trying to cover it from a high level perspective. So you just imagine that, okay, whatever data that is there as part of this block, you just take hash of entire data. That entire data hash, the hash of this entire block will be stored in this second block with this particular term, previous hash, and then the hash which will be there as previous hash. By the name itself, it means this block's hash will be there in the previous, in value of the previous hash. For this particular key, the value will be the hash of this block. Similarly, in this particular block, third block, the value of previous hash will be the value of hash of this block. Okay. Now you might be having a doubt that, okay, if these blocks are having this backward connectivity in terms of the previous hash mapping with the previous block hash, so how exactly does this makes the blockchain immutable? Now we'll think of it in this perspective that, let's suppose I'm giving you one particular word and I'm asking you to convert it into some hashed format. Okay, let's suppose I've given you one word, dictionary. Now the hash of this particular term, dictionary, will be some, let's suppose I'm using any hashing algorithm. Hashing algorithm is something that will just create the hash of any particular data, whatever data that you will pass. As of now, we are just talking about this term dictionary. Now, what will be the hash of this term dictionary? It will be some, just imagine it will be, we are using SHA 256 algorithm. So it will be some 256 bits of the data. Now, we are just talking about the correct spelling of dictionary, which is by default available publicly. Now, let's suppose if someone comes and says, instead of writing Y at the end of the dictionary spelling, I use I. Let's just talk about that case. So in that case, what will happen? The resultant hash will change. It will not be same. So the point here is, even if you will add extra space also after dictionary, you are entering hash and then you are calculating the hash. The entire hash will change. So here we need to understand that this is how precise this hashing is. Now here, when you are saying that I'm calculating the hash of this data, which means there will be, at the atomic level, there will be transactions recorded in this block. And based on the Merkle tree that is there for those transactions, we'll be having Merkle root hash, which is again a hash. Now that hash, along with some timestamp, some other data, some block number, nouns, all these parameters that are there, we'll be having this block hash. So the point here is, if anyone will try to manipulate any transactions, first of all, what will happen? The transaction hash will change. Then what will change? Merkle root hash will change, which will result in change of the block hash. And then eventually that particular hash will not be equivalent to the previous hash value, which is there in the second block. So in that way, what will happen? It will invalidate the entire chain. You will say that, you can say that the block which is having the invalid hash, after that, all the blocks will be considered invalid. And then we can say this, but these blocks will no longer be part of the chain. So this is how immutability is defined in a blockchain. Whenever someone asks you, or whenever you are talking about the immutability, you need to understand it from this perspective, that how exactly we are making the data immutable, and what is there in blockchain which is not there in some traditional technology that makes it superficial, or that makes it something special. So this is one such feature, immutability. Now we have discussed how exactly the immutability works. So I hope this would be clear to all of you, because in the upcoming slides, we will be having one topic wherein I'll try to ask you how this thing can be manipulated. Okay. So any doubts until now? Okay, all right. Let's move ahead. Now we'll try to understand the evolution of this blockchain, how exactly this blockchain thing evolved. So you can think from the perspective that it started with the Bitcoin. So who can tell who founded this Bitcoin? Anyone knows the name of the creator of this Bitcoin? I guess this was also kind of a hot topic sometime back. So you might be knowing. You can paste your answers in the chat box. Satoshi Nakamoto. Okay. Santoshi. No, it was not Santoshi. It was Satoshi Nakamoto. All right. So yeah, that's the correct answer. So in 20, or you can say 2008, basically, we had this Bitcoin application developed, which means it was kind of a anonymous platform. People used to use it to uh, perform some anonymous transactions wherein fiat currency was not involved. It was kind of a virtual currency, a cryptocurrency. So that was the first phase of this, uh, you can say, blockchain thing, which was typically named as blockchain. Now, even then, also people were not exactly aware about this term blockchain. They were just aware about Bitcoin, because you can say it just became famous with the name Bitcoin. Then we came up with some other concept. We thought that, okay, if we are having some specific system which just uses the cryptocurrencies, then why not we can use the same system, not just to use it for the cryptocurrency or the payment transfer mechanism, but also to include some business logic in it. And that is when we came up with the concept of smart contracts. Now, these smart contracts are nothing but whenever you're talking about any business logic, let's suppose you want to transfer some money to your friend. And so this is just a basic condition that we are saying, right? And so you will be transferring it to your friend after your friend completes certain tasks. Now, that particular contract, instead of writing it into some legal contract or something, although it is not related to the legal contract, those contracts are different. Here, we are just talking about writing some business logic. So let's suppose you wrote this entire thing, this entire situation of paying to your friend when some particular task is done. So you just converted this into the business logic in terms of programming, and you just wrote it down into a smart contract. And then, based on the execution of those contracts, your funds will be released and the transfer will be happening. So this is what exactly smart contracts are used for. So this happened in somewhere around 2012, you can say 2012. Then 2 3 years down the line, we came up with some applications. So usually we use these kind of mobile based applications or some web applications, right? But somewhere what they are using some specified centralized servers at their backend. When we talk about the blockchain based applications, it means they are somewhere not related to the centralized servers. They are related to the blockchain network, which makes them decentralized applications. So that is why we just call them dApps or DApps or decentralized applications. Then again, 2 3 years down the line, in 2018, we came up with the concept of NFTs. Now, all these things we'll be discussing in detail. Just to give you a brief about the NFTs, I guess many of you might already be having the idea. So here we are just focusing on the advancement of the blockchain, how exactly the blockchain is evolving. Somewhere around 2012, people just used to think that okay, it would be related to this part only, wherein we'll be writing some smart contracts and then it will be auto executed. We are just performing some sort of an automation in a kind of a controlled environment or in a kind of a decentralized environment. But we had some other concepts that emerged later in form of NFTs, then in form of CBDCs, and recently in form of carbon credits also. Now we'll try to discuss these things in detail going forward. Okay. So I'm assuming you might be having some idea about this term mining. So who can tell me if, okay, just tell me first of all, yes or no, if you have heard about this term mining before. Okay, all right, sure. I hope I'm audible to you all clearly, right? Do I need to speak louder? Okay, thanks for answering. Sure. So when we talk about the mining part, I think you are already aware that that works in a different consensus algorithm, which is proof of work. So can anyone tell me what is the current consensus algorithm which Ethereum is working on? If you have heard of Ethereum recent upgrade, proof of stake. All right. So this is just a visual representation of proof of stake, basically. We'll not be going much into details, but just to give you an idea, the current version of Ethereum, which is Ethereum 2.0, it is running on proof of stake. So last year in September, it just got merged to, so it was known as the merge, wherein it just transitioned to proof of stake from proof of work. Okay. Now we'll just try to discuss some of the use cases that are there related to the blockchain. So as we discussed, it is not just limited to any one field. It is there in multiple fields like supply chain management, autonomous systems, energy grid management, smart cities, identity management, agriculture, and precision farming. I'll just give you a brief about each of these. When we talk about supply chain, you just imagine, I'll just give you an example. You just imagine a pharmaceutical company. It is having, so what exactly do you think when happens when you are going to some shopkeeper and you are asking for some, you are going to some pharmacy and you are asking for some medicine. So what do you think the medicine is coming from? Where is it coming from? Definitely, it is getting prepared at some pharmaceutical company, right? Then in that case, the path that particular medicine is following from its manufacturing until it is delivered to you, this entire thing is known as supply chain. And when we are managing this entire thing, it becomes a supply chain management. Now, ideally, it is done. We are not saying that this is just possible through blockchain. Now, also, it is happening. But to counter some of the limitations of supply chain management. So, one such limitation is we can see there are multiple counterfeit medicines that are created, right? Some fake medicines are created and then they are also circulated into the market. Now, this is not good from the health perspective. This is not a good practice to be followed from the uh, entire ecosystem which is there. So, in order to avoid these kind of things, these kind of uh, in order to handle these kind of negative scenarios, we just came up with a solution that was very useful in terms of making this entire chain traceable. And also, we'll be able to detect the movement of the goods across each and every stakeholder. So this is how exactly the supply chain management leverages the capability of the blockchain. Then we have autonomous systems. Now, what do we mean by the term autonomous? It means something which is self-governing. So when we talk about self-governing, it means the system here is intelligent enough to take its own decisions based on the inputs provided. It will be able to calculate it. Now, again, I'll just give you an example. Let's suppose you are booking some flight, okay? And normally, if it gets delayed or if the flight is cancelled from the flight provider, so there is a very tedious process in order to get the refunds. Now, we'll just not talk about the cancellation part of it, but we'll focus more on the delay part. Let's suppose there is a delay in the flight, or let's suppose some of the services were there which you were not able to utilize, or there was some issue with your journey. It could be anything, right? Now, all these things, usually, whenever we say that normally people might not be facing, but let's assume that you are having some connecting flight, which you have not booked as part of the single journey. But let's just assume you booked some flight and then you booked some maybe you had some train, maybe you had some bus or any other mode of transport which is running at fixed interval of times. Now, in that case, what will happen based on the delay? You will be missing the subsequent travel also, right? But you can't state this thing to that person or to the airline that due to your delay, I am now not able to travel my subsequent part of the journey. So please refund me my amount. This can't be done, right? So they'll say that, sorry, sir, if there's a delay, what we'll do, we'll just transfer you to some other flight or we'll just reschedule your flight. This is what usually they'll allow us as part of the options. Now we are just talking about a kind of a use case. Now let's just put this entire thing as a self-governing system on smart contracts using blockchain. Now what we'll say that, okay, you just write these conditions on the smart contract. And then we'll be having some IoT devices, some devices that will be passing in some inputs based on the situation. Now, let's suppose some flight was there which got delayed. So this input will be taken in from some IoT device, let's say in terms of some timestamp or something. And then based on the calculation of the contracts, whatever the logic that we have defined, that okay, if there is a delay of more than 30 minutes, then some specific amount, some partial amount will be transferred back to the user or the person who booked the flight. So in that case, what will happen? we'll be able to understand that, yeah, now there is a self-governing system. We need not to run around the counters in order to ask for the refunds. Everything is kind of automated in a self-governing environment. That is what we say autonomous systems. Then we have energy grid management. Now, this is something new. This has not been implemented yet, but again, I'll just give you a brief about this. You just think of some sort of a mechanism wherein whatever electricity that you are consuming, you are able to tokenize it, and then you are able to figure out that, okay, how much amount you will be paying for some specific consumption. Now also it is happening. You might ask, what is the issue with the current system? So we are not saying there is some issue, but just to make it more efficient, when we are talking about natural resources, which means the energy that we are obtaining from, let's suppose, solar panels or something. So you can just you can just use blockchain systems to create some kind of a regulated environment to manage the grid, to manage the energy in terms of some packets, tokens, and then you can just leverage the capabilities in an efficient manner. Then we have smart cities. Again, these kind of things are possible using IoT. Nowadays, we all know that we have Google Home, we have Alexa, we have all of these uh, automated voice systems, right? Now, let's say if we are just using our voice commands or something, it just performs some specific task. If you want to switch on the AC when we are traveling somewhere else, if you want to switch off something, if you want to open or lock the door, all of these kind of things are possible through some IoT devices. So this is also one of the parts when included along with the blockchain, it can make your ecosystem smarter as well as secure at the same time. Then we have identity management. Now we'll try to focus more on it while discussing about the identity part. Then we have agriculture and precision farming. So again, whenever we want to automate some system, but then we want it to be in such a way that it should not be having any anomalies in it. It should not be having any limitations. No one can uh, manipulate the data. Let's suppose you are using some uh, irrigation system in your farm, and then someone just hacked into your system just to maybe there could be n number of malicious purposes, right? So we can't just discuss those purposes, but let's suppose someone just tried hacking you in. We are just discussing that possibility. Or it could be like, let's suppose you are not able to take care of some specific schedule based on which uh, there was a loss of some crops or some issues you faced during the farming process, during the irrigation part. So all these things, if we want to automate in a kind of a restricted environment, by restricted we means secured environment. So that is what we can achieve using the blockchain. Now, in order to go in depth, how exactly it can be done, or what could be the challenges that we might be facing, then we'll have to go deeper into that, right? But as of now, we are just saying that, okay, these are the things. It is not just limited to these use cases. There are n number of other use cases as well. But just to give you a brief idea that, okay, there are multiple systems wherein blockchain is very widely used. And we are just not talking about the concepts here. If you talk about the current scenario, so there are multiple countries, and even if you talk about our own country, India, there are multiple states who have started utilizing blockchain for various use cases, like this land registry mechanisms is one of them, right? So until now, we have seen that what exactly is blockchain, what are the use cases of it, right? But overall, we just got the idea that, okay, blockchain is cool, but it's not without its challenges. So again, to give you an example, you just imagine a super busy highway. Now, highway, we all know highways are there for better connectivity, for uh, for whatever purposes it is, you already know, right? Now, as more cars try to use it, it gets jammed and then things slow down. So that is what scalability is as a challenge for blockchain. When too many people are there who are trying to use it at a concurrent time at once, then the speed drops and the fees will definitely go up. Another thing to consider here is the energy. Some blockchain platforms like Bitcoin, they just try to use a lot of energy because we all know what exactly a mining is. It requires some specifically designed application integrated circuits to usually solve that puzzle that is there. Think of it like a big puzzle that computers solve to keep things safe. But solving this puzzle takes a ton of energy, and people just worry about the environmental impact. So this is one of the key challenges that is there. Now, although there are blockchains that have already resolved these challenges, but yes, when we are just talking about the challenges, this is one of them. Next is lack of interoperability. It means, let's suppose if we are having, uh, if you are using some particular platform, if you are using Ethereum and you are having ETH with you, which is the Ether, the native currency of the Ethereum. And then let's suppose at some point of time you wish to use some other platform, some other decentralized application that came up using some other platform, which uses its native currency as something else. Maybe it could be some Cardano or Bitcoin, anything. Then in that case, what will happen? You will not be able to use that application using your existing cryptocurrency, that is Ether, because Ether will not be working on some platform that just supports Bitcoin. Now, what do you think this problem is? This means those two blockchain frameworks are not interoperable, right? So this is also a kind of a challenge. Then we have governments and rules. So blockchain is like a new kid on the block, and then regulators are just trying to figure out how to keep things fair and safe. So this is a kind of a major challenge. Without proper rules, there can be risks like scams, frauds, money launderings, all of these things, right? So we definitely need to have some defined regulatory and legal frameworks to control the usage of this entire technology. Then we have integration with legacy systems. Now, what does this mean? This means we are already having some highly developed build systems with us. Now, whenever we are talking about the blockchain based systems, which means the blockchain is kind of new, and whatever systems that we are using so far, they are already existing. Let's talk about some payment based mechanisms. Let's say if you are using, you might have used ATMs, right? So you can't say that I'm having this cryptocurrency and I want to take out some cash from the ATMs. Now, here comes the challenge, which is regarding the integration with the legacy systems, which means the ATM machine is using a kind of a traditional legacy system, which cannot be integrated with current set of technology, which is the blockchain here in our case. So this is also one of the challenges. Then we have quantum computing threat as well. Now, this one specifically we'll try to cover in our upcoming slides. Okay, so these are basically the challenges. Now, blockchain is just like a super smart digital book that can change the way we do things. It is secure, it is transparent, it can be used in many ways beyond just money. But remember, just like any superhero, blockchain also is having its own challenges. Scalability, energy, rules, user friendliness, all these things kind of need attention. And as we move forward, blockchain will evolve even more. It will find new ways to make our lives better, from tracking food to voting with confidence, all of these things, right? So we'll see what is next here. Solutions for the challenges. So the first challenge that we saw, scalability. Now we know what exactly is the challenge with the scalability. When we are having multiple users and they all are trying to use the network on the same time. So what will happen? Apparently, the gas price will increase. So to overcome this scenario, now I'll just give you the names, some of the names here, and then we'll try to discuss few of them in detail. We have the sharding which is there available on Ethereum and then Zilliqa. Then we have layer 2 solutions, Lightning Network, state channels. Then we have side chains. Again, we'll not be going into much depth because it might take uh, a huge amount of time to explain you these things, right? Then we have energy consumption as one of the other challenges. So those challenges are being resolved using the new consensus algorithms, which is proof of stake, proof of authority. Then we have regulatory and governance challenges. So how these are overcome? Self-regulatory organizations are there. We have Global Digital Finance, Crypto UK. These are the platforms. Then we are trying to collaborate with the regulators. So we have blockchain associations, global blockchain business councils who are helping out different countries and different regulatories authorities to overcome these challenges. Then we have integration with legacy systems, which means we have smart contract oracles, we have interoperability protocols. So all these things are there to resolve the interoperability challenge. Then for the quantum computing threat, this we'll try to discuss in detail. Although we are having some quantum resistant algorithms as well. And then we have quantum resistant blockchains also. So when we talk about interoperability and cross-chain, what do you think it is? It means the abilities of different blockchain networks, as we discussed, to communicate and exchange the data seamlessly. Like let's suppose you are having uh, your account created on MetaMask on top of the Ethereum network. Now, what you will be doing, you'll try to access some data. You'll try to have some data over there because since your application is based on the Ethereum network, and then you are having one more application which is based on, let's assume, some other network, Cardano network. So what will happen? You will be using different applications, but at any given point of time, if you are planning to use those applications in a seamless manner, that will not be possible. So that ability or the possibility of allowing that particular communication is possible when we are having some sort of a interoperability mechanism. Now, to enable these communications, we need to have some sort of a mechanism. Some channels should be there, some bridge should be there, or something like that sort needs to be there when we are talking about making that connectivity. So we have multiple solutions that aims to break down these silos that are there and also tries to foster the collaboration, also tries to leverage this capability that, okay, if we are having different blockchain platforms, then how exactly we can make them interoperable? How exactly we'll be able to, transfer some assets. Now, assets could be anything. It could be the cryptocurrency that you are owning. It could be the details. It could be the data that you are having. All of that can be considered as an asset. So that asset transfer, along with the cryptocurrency transfer, when it is possible, that is something which we say is resolved using interoperability and cross-chain solutions. So there are some frameworks like Polkadot, Cosmos blockchain, which are trying to work on this. We have Chainlink as well, and many more are there that are existing in the market. This is just to give you an idea on the few. Now, next part here is about the decentralized finance, or we can say the blockchain finance. Again, just imagine a world where traditional banks are just one option among many. A world where you can borrow, land, trade, invest without middlemen, paperwork, or the hassle of the traditional finance. Right. So normally, let's suppose if you are going out there to uh, take out some particular some land-based loan, or you want to uh, trade something, you want to invest somewhere. So everywhere, wherever you will go, you will find out some middlemen, some paperwork would be there, and then you will be facing some hassle while doing all this process. So when we talk about the decentralized finance, so blockchain technology here is kind of reshaping this financial landscape. Now you need to picture this: a global financial playground which is open to everyone, running on the lines of the code. That is DeFi. It's just like a digital playground where you will be having access to all sorts of financial services, just like savings, loans, trading, and more. Like, let's suppose without relying on the banks or the brokers, instead, smart contracts, the self-executing agreements written in the code will handle these transactions. So what will happen? It will make them more secure, more transparent, and free from the intermediaries. Now here, if we try to break it down with examples, say you want to earn some interest on the cryptocurrency, right? In the traditional world, what you will do, whatever money that you are having. So what exactly we do for maximizing the profit? We try to invest it, right? So usually we'll be putting it into our savings account. Most of the people will be putting it into their savings account, and then some will try to invest it somewhere. Some will try to invest it in stocks or mutual funds, whatever options that are out there available, right? But in the DeFi world, you will be using a decentralized lending platform. You will lend your crypto, which means you will give it as a loan, and borrowers will pay you some interest. Now, here, no banks will be involved, just the lines of the code that are making everything secure and make sure everything works smoothly. This is what this DeFi will be doing using the blockchain. Now, whenever we are saying everything will be happening on its own, so you need to understand that it is not just like there is some particular owner to this. The decentralized network in itself plays the role of the aggregator. So there is no middleman here. The power is distributed amongst the nodes, amongst the validators who are there, amongst the miners, all these stakeholders that are there. They play a very important role in validating or verifying the transactions. Now you can also think of swapping one cryptocurrency from another. Let's suppose you were able to make some platform interoperable. Now you are uh, at the situation where you are able to create some swap based platform. You are swapping one cryptocurrency from another. So in DeFi, what you will do, you'd use a decentralized exchange, just like trading on a stock market, but without the stockbrokers. Your trade will happen directly with another user, and thanks to smart contracts, they'll be coming in, bringing the transparency and also reducing the risk of the manipulation. Just like normally, we are not saying that it happens most of the times, but there might be chances when we have risk of manipulations in the stock markets or any of these markets which are involving some middlemen, right? So usually, if I will have to give you an example, if you'll compare different stock market platforms, trading platforms, you'll see there is a lag or there is sometimes a difference between the exact price, that pricing, because at the end, what they are doing, they are also uh, updating those prices based on some input, right? So there are chances of the data being manipulated. There are chances of the data being uh, falsified. So all these chances are there. Now to overcome these things, we have this DeFi here. We have this concept of decentralized exchange. So it's just like the stock market only, but here it is controlled in a decentralized manner. No one is governing it. No one is controlling it, right? So usually you will ask, why should you care about DeFi? Well, first of all, it's inclusive. Anyone with an internet connection can join. You need not to have a fancy suit or account manager for you. It just empowers all of you as individuals who were previously excluded from the traditional financial system. Right now, you will be having the ownership of your own funds. It's also fast. Transactions that you will be doing over DeFi platforms are processed in minutes, not days. It's not just like, let's suppose you purchase some stock or something, so its documentation will take some time, and then at the end of maybe 4 to 5 business days, you will be getting the notification on your mail saying that, okay, these particular stocks are now uh, added to your account. Right here, it is instant. It is a kind of a 24/7 nature of the blockchain, plus the transparent nature of the blockchain, which will allow you to track each and every transaction and verify its authenticity at the same time. But again, here also there's a twist. So DeFi is not all the sunshine and rainbows. When we talk about this, it's incredibly promising, but it's also risky. Think of it as a kind of a wild west of finance. Smart contracts can have bugs, then leading to hacks, losses. And since these DeFi platforms are often new and experimental, they might not have same level of regulation and security as we have in our financial institutions. So we have regulatory authorities over there. We have SEBI in India, right? We have different stock depositories are there. So all these organizations are running within a level of regulation. But when it comes to DeFi platforms, so it is still immature. It is still maturing in its own way. So from that perspective, we are saying that, okay, it is having its own challenges. But at the same time, it is also having the advantages, like higher liquidity is there, lower transaction fee. You can easily access your financial services without having the bank accounts. Then what exactly are the platforms that are uh, allowing this DeFi? So if you want to explore, you can check for AnySwap, Uniswap, and Yearn Finance. So next we have the non-fungible tokens or the digital assets. Now this is the realm of NFTs, or we can say non-fungible tokens, where blockchain is turning intangible creations into valuable and verifiable assets. When we say intangible creations, what do we mean by that? Now let's start with the basics again. Imagine you are having a digital painting. Now you want to sell it, but how will you prove it's original? You will not be able to prove it unless you are having some sort of proof. Someone saw you picturing that, and someone is having that video recording of yours picturing that entire painting or painting that uh, entire thing, and then only you can prove it, right? But these are just imaginary things. Now that's where NFTs comes in. So NFTs are like certificates of authenticity for these digital items. They are unique tokens that are indivisible and cannot be exchanged on a one-to-one basis like regular cryptocurrencies. Which means, let's suppose, if we'll talk about the fungibility, which means the value is fixed. It's just like you will say, I'm having this cryptocurrency, I'm having this one Bitcoin. So can anyone write in chat the current value of Bitcoin, if anyone is aware of? What do you think is the value of one Bitcoin currently? People who have okay, so the last time you were having any idea about the Bitcoin, you can mention that price as well. 20 lakhs. Okay. Yeah, that is close to correct. So the current value is somewhere around 23 lakhs INR, right? 2.3 million to be exact. In yeah, 2.3 million. All right. So anyone aware about the all-time high? What was the all-time high of Bitcoin? One Bitcoin. Here we are talking about the price of one Bitcoin. 40 lakhs. All right. That is correct. So it was approximately 40 lakhs. Now, whenever we are talking about this thing here in terms of the Bitcoin, so let's suppose uh, if you will say, I'm having one Bitcoin, would you like to trade? So what will that person say? The person will say, okay, sure. How much do I need to pay? Then what you will say? You'll say, see, the value of one Bitcoin is equivalent to 40 lakhs. Let's just imagine it was at its all-time high price. So at that particular moment, you will say, how much should I pay? So now there is no scope of bargaining here because it is having a fixed value. And also there is no such concept of uh, defining its value. You can't say, I think your one Bitcoin should be equivalent to 4 lakhs, not 40 lakhs. You can't say like that, right? That is not possible. So in that case, you will have to accept this particular logic. You will have to accept the price. you'll have to accept the fungibility. So that is wherein we can say, okay, I'll pay you 40 lakhs worth INR, and then you just transfer that one Bitcoin to me. This is when we are talking about the fungible tokens. But when we talk about non-fungible tokens, which means the value cannot be decided by the external world, just like that. It cannot be fixed. You can't say, let's suppose, if I'm having one NFT, you are having your own NFT. Now we can't say that our NFTs will have same values, because we are having these NFTs built on top of some digital art, some those kind of assets which have a variable value. Just like, let's suppose, if I'm saying, uh, let's say, if we can talk about a music album. Now, no one can project the exact cost of a music album. Let's suppose if I'm giving you a song, a music album, you can't say, okay, this feels like it is around $5,000 worth or something like that. You can't say. You can't give an exact pricing for that, because it is non-fungible. The value is not exactly tradable in terms of the fixed format. So NFTs have this property of creating unique pieces. It just artists just tokenize their particular digital art into NFTs, and then they just sell them on digital marketplaces. So buyers in turn will get the original version with the ownership recorded on the blockchain. So it is just like owning the Mona Lisa painting, but in the digital world. To give you one more example. So every day is the first 5,000 days. This is a kind of an NFT which was created by an artist known as Beeple. So you won't believe, but it was sold as an NFT for around $69 million. Now this marked a historic moment in the art world. This just demonstrated the immense value of digital creations. So this is a kind of an album. You can just search for it. Every day is the first 5,000 days by artist Beeple. So even beyond the art, we are not just saying that it is limited to the arts or artistic things. NFTs don't just stop at art. They are branching out into music, gaming, virtual real estate, and also in sports history. Right. So in the gaming realm, we have these virtual real estate, uh, or we have some assets. These are which are becoming kind of a hot commodity. So you can imagine buying a piece of land in a virtual world and then selling it out for profit, just like in the real world. So we have one platform such as Decentraland, which is a virtual reality platform. So it allows users to buy, develop, and trade virtual land using the NFTs. Now the land would be in, you can imagine that the land would be in real. It will just be like you are owning that land in real, but the value is being traded in terms of the NFTs, in terms of the non-fungible tokens. Okay, so if we'll talk about the gold, Bitcoin, so what do you think? What is gold? Is it fungible or non-fungible? You can write it in the chat. What do you think of gold? Okay. Utsav says fungible. Naveen says fungible. What about others? Fungible. Soumya says fungible. Okay. All right. So that is correct. Gold is fungible. Yeah. What about Bitcoin? What do you think? Fungible. All right. And what about some unique avatar? Let's suppose if some unique avatar is there, just like this piece, which you can see here. What do you think? Is it fungible or non-fungible? Non-fungible. Correct. That is correct. So I think now you are able to understand what exactly do we mean by some asset which is non-fungible, right? So a masterpiece by some artist, a music album. So all these things are something which we can't give the exact value. We can't say that these are having some specific value. So that's why we are putting them into the bucket of the non-fungibility. And whenever we are trying to tokenize these things, so we are not just talking about their value or their particular price, but we are also talking about the key factors, the other two key factors, which is the ownership as well as the scarcity. Ownership, you all know. Who is the owner of this particular music album? That is ownership. What do you mean by scarcity? Now, scarcity comes into play because many NFTs are released in limited quantities. Think of it like you are having a rare Pokemon card. Right? What happens in that case? The fewer there are, the more valuable they become. So this is just like that. When you own an NFT, you are the only one with that particular specific token. Now this might provide you a sense of exclusivity, which means you are the exclusive owner of that particular token, right? Now we have examples such as CryptoKitty, Board Ape Yacht Club. So these are some of the famous examples that we have. Now there are multiple other NFTs as well, but these are the most famous ones. Next, we'll talk about other interesting field, which is blockchain and IoT. So when we talk about blockchain and IoT, it just opens up a realm of possibilities that redefine how we exactly interact with our surroundings. You just imagine waking up in a house where your coffee maker just starts brewing as soon as your alarm rings. Your thermostat adjusts to the perfect temperature, and your car knows your preferred route to the work, to your workplace, to your office. So that's the magic of IoT. We all know what is IoT, a network of interconnected devices that share data and work together, right? But here's the catch. With all this data flying around, how do we ensure it's secure, accurate, and tamper-proof? Let's suppose you were having this automated car driving system, and whenever you are passing the data to these sensors, IoT devices, which means somewhere these devices are connecting within each other, within an ecosystem. Now, what if some malicious hacker is there who is trying to manipulate the data? That hacker just gave some wrong signals, some data manipulation was done in order to manipulate the speed of the car, or maybe the destination, or maybe to hack the sensors. Now the sensors are giving the signal that okay, someone is there ahead of your car, and still that since that system was manipulated, so it just overpowered that logic which was written. So what will happen in that case? Even if it is based on the AI, even if it is based on the IoT, so you can see even having this much power, the system becomes prone to these kind of attacks and these kind of hacks. So that is where blockchain comes in, to make it secure, to make it accurate, and to make it tamper proof. So blockchain, IoT, and AI. So these are like a kind of a dynamic trio. IoT generates massive amounts of data, and blockchain ensures that the data is trustworthy and also it is transparent. It is just like giving IoT devices a digital notary. You know what is notary, right? To validate the actions of the data, whatever the IoT devices are doing. Now you can just, again, we'll take one more example. Imagine you are having a smart fridge that orders groceries for you based on whatever you are keeping inside the fridge. Let's suppose you are fond of some green vegetables. So based on some sensors that are there inside your fridge, it will just order groceries for you. It will just say that, okay, now only 2 apples are left. And this person usually keeps the rack full with almost around 5 to 6 apples. So what will that fridge will do? We're just talking about a hypothetical situation here. I'm not sure if that kind of fridge is existing in the market. But again, let's just take the example. So smart fridge will just order the grocery for you. It will just order some specific grocery. So with blockchain, you can be sure that the orders are genuine, they are not tampered with, and also the payments are secure. Right? Otherwise, anyone can do anything. But we need to put some restriction. We need to put some stamp. We need to put some validation stamp on this. And that is where we need to have this blockchain. This combination brings a layer of accountability that is very much crucial for the trustworthiness of IoT systems. Now you can have multiple IoT areas, IoT devices, but they won't be considered as trustworthy unless you are having the data validation. And that is possible with the usage of the blockchain. Now, one more area is there where blockchain and IoT usually shine. Let's say you buy a shirt from a store. So using IoT sensors, you can trace that shirt's journey from the cotton field to the shop's shelf. Now, blockchain will record every step, ensuring transparency, reducing fraud, and enabling you to make more informed choices. Same thing is applicable on the medicinal supply chain also, just like we discussed in the beginning. We will be having IoT sensors. Same thing we discussed for the farming and irrigation part also, right? So everywhere we will be using IoT sensors only. We need to have some sensors that will be sending in the data to the blockchain network. But in order to validate everything, in order to prevent fraud, and also to maintain the transparency, to make more informed data-driven choices, we need to have this association. We need to have this collaboration between blockchain and other technologies like IoT, right? So we have multiple projects on these IoTs also. So if you'll talk about this IOTA, then we have other projects also. Chainlink is also there that is working on the concept of bridging oracles with the blockchain. So they are coming with the concept of decentralized oracles. Oracles are devices. You can just, for now, you can just imagine them as IoT sensors that are passing in data from the external world to the blockchain. So that is why we just call them oracles. Okay. So next we'll talk about the environmental impact and sustainability part. So just think of from this perspective that in a world we are living. So we have increasingly focus on the sustainability part, the intersection of these cutting edge technology and environmental consciousness. So it has now become, you can say, a paramount concern. Everyone is concerned about these things. Let's suppose whatever products that you are building nowadays. So even from the investor point of view, or even from the evaluator point of view, the advisory point of view, all these will be concerned about the sustainability of it. Let's suppose you are coming up with a product now and you are saying, see, this blockchain product I've created and this uses Bitcoin and this uses proof of work. Let's just forget Bitcoin, but you are still using proof of work or mining. So what will happen in that case? Which means you are still dependent on the high energy consumption. Now that means you are not exactly making your product towards a greener future. You are not making it sustainable. So this is what exactly we say when we talk about the sustainability part or the environmental impact. So there is this term known as the energy conundrum. So when we talk about this energy conundrum, so it means, let's just start by addressing the elephant in the room, energy consumption. So many blockchains which usually use proof of work like Bitcoin, so they require substantial computational power, right? Now this typically leads to concerns about the carbon footprint, and then it is associated with mining activities, and then huge energy consumption across the globe, across the countries. So these are just energy hogs. But if we are just naming our blockchain with that perspective, so what it will do, it will just bring a bad name to the blockchain. Like people will just start uh, believing that, okay, this is not for good. This is not for the betterment of the environment. So that is why we need to think from that perspective also. We need to think from the environment perspective. We need to think from the sustainability perspective. So there are multiple blockchains, multiple, you can say, uh, progress has been made in this field. Proof of stake is one such step taken by Ethereum towards sustainability. Now it can also facilitate the integration of renewable energy sources into our grids. Right? Like let's suppose, imagine, you can imagine solar panels generating excess energy during the day, and then blockchain could help that energy to manage the distribution and trading of surplus energy amongst homes and businesses, just like we were discussing about the smart grids, right? So just to give you an example, in Germany, we have this Brooklyn microgrid project. So this project typically uses blockchain to enable residents to buy and sell locally generated solar power. It's just like you are having solar plant installed in your home, and what you are doing, you are selling that particular solar energy to others. Now, this not only promotes clean energy, green energy, but it also empowers communities to take control of their energy sources, right? Now, until now, I don't see anything wrong with this because here we are using or utilizing the blockchain, and we are also thinking from the environment perspective, right? Another exciting aspect could be carbon offsetting. What is that? Blockchain can make tracking and verifying carbon offsets more efficient and transparently. Companies usually just will be tokenizing the carbon credits on the blockchain, which will make them easily tradable. Now, this will just stimulate a kind of a marketplace for businesses to invest in these kind of initiatives. So whatever products that you will be coming up with, if they are more inclined towards the green initiatives, if they are more inclined towards these kind of uh, these kind of initiatives like renewable energy, green initiatives, carbon offsetting, carbon credits, offsets. So there are high chances that it will be selected as a good product because at some point of time we just need to standardize our product, like whatever we are creating. Now, since I'm assuming and believing that many of you might be from the non-tech backgrounds. Let's say if someone from you is from some mechanical background, electrical background. So you might be having very good idea of the machineries, right? But at the same point of time, if you will see those machineries when you are making them digitalized, so you also need to measure the amount of fuel that they are consuming, right? So I believe most of the machines might be there out there which have started tracking the fuel consumption and all these things. But at present, if you are building something like that, and if you are not thinking from the sustainable perspective, so do you think your product will strive and thrive in market? It will not be able to uh, sustain in the market because it is not taking any new initiatives in terms of saving the environment, right? So there is this Energy Web Foundation, for example. It uses blockchain to support renewable energy markets, and then we have this EV Origin, which usually certifies the origin of green energy using the blockchain technology. So there are multiple other solutions out there. We are just focusing on this more because now when you will be going into the market for the jobs of blockchain developers, you will not be working on some traditional kind of technologies. It is completely different. You need to change your mindset also. You can't just imagine that, okay, I'm working on some just digitalizing something. It will not be like that. You will be working on some completely out of the box thinking. You will be working in realms of uh, electronics, or it could be e-waste. You will not be thinking it as uh, some sort of a product. It will be more like a kind of a ideology that you will be working towards, a sustainability, right? So next we have is blockchain and governance and identity. Imagine a government where every decision, every contract, every vote is recorded in a way that is tamper-proof and transparent. Now that's the promise of blockchain and governance. It introduces a level of transparency that we have never seen before. Just to give you an example, in West Virginia, they have started using blockchain to enable secure remote voting for military personnel who are stationed overseas. Now, this usually allows them to cast their votes transparently and securely. And this also eliminates concerns about fraud or tampering the data. Now, the idea here is if we'll talk about the identity, we live in a world where personal information is scattered across countless databases and making identity theft as a constant threat. So, over the past decade, if I'll tell you, there have been multiple breaches where the identities were stolen and sold in the dark web. We have this black market where the identities are sold along with personal details. So all of these threats, all of these uh, things that are happening. So these can be controlled when we are trying to secure our sensitive data. For instance, Microsoft is also working on this identity system known as ION. Now that aims to give people control over their own identities. With blockchain, what you can do is you can prove who you are without giving away more information that is necessary. This is also something which comes under the zero knowledge proof. That is also a kind of a buzzword when we talk about the blockchain development. So one more concept is self-sovereign identity, which means your identity will be defined by you and you will be the owner of your own identity. No one can control your digital identity. That's where this self-sovereign identity powered by blockchain comes into the picture. Then we have this decentralized autonomous organizations also, DAO, right? So all these things allow us to have transparency and trust in the governance systems. Then we have individuals which are able to control and share their digital identities securely. You will just share whatever data is required. So we are having multiple platforms that usually are working on these decentralized identities. We have Hyperledger Indy, we have Polygon ID, right? Then we'll talk about one of the major topics, quantum resistant blockchains. So we'll just try to uh, think this from the perspective. You just try to picture this that a computer. And I think you all might be having a good understanding about quantum computers until now. You might have seen some posts, or you might have heard about the quantum computing, right? A computer that is so powerful that it can solve complex problems in fraction of seconds. Now, just imagine a calculation that would take classical computers millions of years. It can be solved by the quantum computers in fraction of seconds. That's the power of quantum computers. Now they promise to revolutionize industries from healthcare to finance, but they also pose a major threat to the security of current cryptographic methods. So the question is, can quantum computers break the cryptographic algorithms that are used in blockchain? What do you think? You can mention in the chat. Yes, no, probably yes. Okay. All right. So the answer is kind of a subjective here. It depends what exactly is the algorithm, what is the mechanism which we are talking about, which cryptographic technique we are talking about. Now, if we talk about some cryptographic technique that just requires some specific manipulations, then it can be easily done. But let's suppose if there is an algorithm which you have made quantum resistant, which means you are using some mathematical structures that are hard not just for classical computers, but also for quantum computers to break. So we are not just talking about the calculation of PNCs or calculation of some data uh, in some possible combinations. That can be easily done by quantum computers. But here we are talking about the longevity of the data. We need to ensure this longevity, which means you just need to imagine if a quantum computer could break the encryption, it's not a risk we can afford to ignore, right? So we need to think in terms of the data which we can keep as an attack resistant from these kind of computers. So there are multiple techniques that are there. So what's the solution basically? The solution is when we enter the realm of quantum computers, we need to think from that perspective. We need to think from quantum resistant cryptography. It's just like creating a fortress that's immune to the power of quantum computers. Now, these computers might rely on the difficulty of factoring large numbers, but quantum resistant cryptography usually uses techniques that are not that easy to break even by the quantum computers. So just to give you an example, there is this lattice-based cryptography, for instance. It uses mathematical structure, which is very, very difficult even for quantum computers to break. Now we'll get into some other time, get into it some other time, because again, it will take also a lot of amount of time to explain. Then we have all these solutions. We have the QRL, quantum resistant ledger is there. We have quantum resistant blockchains, and we have these algorithms, XMSS, Bliss, NTRU. Now these might sound uh, like some big words, but yeah, these algorithms in itself are advancement of the traditional Merkle signature scheme that usually protects the quantum computers to break the algorithms. Now, if we'll talk about the emerging trends and future predictions, so what do you think? We have privacy preserving DLTs. Privacy has always been a concern in the digital age. So we have these zero knowledge proofs, which means we'll just share the data that is required to be shared, or else we'll just have some techniques that will allow for confidential transactions without revealing sensitive data. So we have this Zcash, for instance. It's a cryptocurrency that uses zero knowledge proofs to enable private transactions. So none of the information is shared in that particular case. Then we have L2 scalability solutions. What are these? These are just like L2 solutions means layer 2 solutions. Uh, so the current emerging research is focused on creating solutions like sharding, layer 2 protocols, state channels, side chains, all these things which we discussed, right? Then we have autonomous machines with blockchain. We discussed how IoT is helping in transforming the cities into smart cities. And then we are using blockchains also in order to make them more secure, right? Then we have metaverse. So I'm pretty sure you might have heard about the metaverse. Now that is something which is again a kind of an expansion of the 3D realm, 3D world using some different techniques like some. So usually there is this language 3.js which is used to create these augmented reality and virtual reality based platforms. And then we have NFTs also associated with these avatars, right? And then we have decentralized AI and IoT networks. And at the end, we have AI driven smart contracts. So you can just think of it as like uh, a solution in which artificial intelligence is driving the smart contracts. Now, in that case, it will never be able to reach beyond the limit which is kept, right? So these are all the emerging trends and future predictions. Now, when we just say about emerging trends, it's not just that, okay, you are just talking about futuristic concepts. But even now, when you will be going out into the market, you will certainly be working on one of these areas. You'll not be working on anything less than this, because these are the current emerging trends, and these will be the things which will be there, which will be shaping our future using the blockchain. So if we'll talk about the crypto adoption also, or not just crypto, but the adoption of the blockchain. Now, since you all are, I mean, some of you are new to this blockchain. So now, since you joined the session today, so at least you got some idea about the blockchain. And once you will be knowing more about the blockchain, which means somewhere you are also becoming part of this community. Somewhere you are also becoming aware about this crypto space, this blockchain space, right? So just like this, if we'll look onto the numbers, this adoption started somewhere around 2012 or something. So here it shows from 2014. So starting from, so this is in million, these numbers. So it was somewhere around 1 million or something in the beginning, because 2009, this Bitcoin thing started, right? So there were some users. We can't say that only Bitcoin was there, no user was there. There were definitely some users, but in trillions of users, if there is only 500,000 users, so you can say it's uh, very less, right? Then gradually it just kept on increasing. So by 2018, we were having almost around, you can say 12 million of users. And then within just 2 years of span, you can see there was a jump of almost around 100 million users, almost. So this is an exponential growth, we can say, right? And then again, in the past 2 years, if we'll see, we had a jump of almost around 20 to 30 million users, which is again expected to be around 200 million users by the end of 2030. Now, this is the data which has been calculated by World Bank and also by some other stakeholders which are there into the crypto space, right? So we can say that the adoption of blockchain, the adoption of crypto is not just any bubble. It's not just any bubble. So there might be people out there, as I mentioned in the starting, who might claim at times that okay, if this blockchain space is a bubble or not. But we have covered multiple topics which might have given you the clarity that it is not just related to some cryptocurrency or something. It is having its involvement at each and every place where we talk about the data, where we talk about the privacy of the data, the security of the data. So, in short, we can say blockchain is definitely there in the future. So, I guess this brings us to the end of this session from my end.